Hello and happy Monday. As you have figured out, I'm not at school today. I am home quarantined. Everyone is doing all right. No symptoms as of yet. Let's go ahead and get started. We are working on the rational root theorem. So far in Unit 2, we are still solving for x. We are still looking for the roots or the zeros or the solutions to a polynomial. We're looking at, or have looked at factoring, completing the square, the quadratic formula, and now the rational root theorem. Rational root theorem gives us a list of possible solutions or roots, and we have to check to see which ones are the actual roots. So I'm on number 1, and I'm looking at 4x cubed plus 9x squared plus 6x plus 1, and I am going to label p. Ooh, that is way too thick. Let me thin that out a little bit. And I'm going to label this up here Q, and that is the number 4. What I need from those are the factors. The factors of P are plus and minus 1. The factors of Q are plus and minus 1, plus and minus 2, and plus and minus 4. Taking those, we're going to build a P over Q list. This is the list of possible factors. And I want to emphasize possible. These are not the ones that are actually going to be true and actual. These are the ones we're going to have to test. So I have my P over Q list. That means every P has to go over every Q. So I have 1 P, so I'm going to write all my Q's just once. 1, 2, and 4. And now my 1 for my P goes on top. 1, 1, and 1. What that gives me is a P over Q list of possible factors. 1 over 1 is 1, so plus or minus 1. Plus or minus 1/2. And plus or minus 1/4. That's the first part of this, is building the P over Q list. This is what I need to start the next step. Once I have this, I need to go back and use synthetic division. Using the values from number 1, I have 4, 9, 6, and 1. I can't tell if that was a positive or negative 1. That was a positive 1. Everything was positive. All right, let's go back to... I'm going to start with a positive 1 from my list. So using positive 1, I bring down the 4. 1 times 4 is 4. 9 times 4 is 13. 1 times 13 is 13. 6 plus 13 is 19. 1 plus 1 times 19 is 19. And I get 20 as a remainder. Not going to work. That is not a root. I will go back and try 4, 9, setting this up again. Trying negative 1. Bring down the 4 again. Negative 1 times 4 is negative 4. 9 minus 4 is 5. Negative 1 times 5 is negative 5. 6 minus 5 is 1. Negative 1 times 1 is negative 1. That gives me 0 as a remainder. This is a root. From my list of possible roots, negative 1 is indeed a root. I can now take these values 4, 5, and 1 and use them in synthetic division. Let me do that off to the side. Oh, I need more colors. 4, 5, 1. I'm going to try -1 again to see if it might be a double root. Bring down the 4. -1 times 4 is -4. 5 minus 4 is 1. -1 times 1 is -1. 1 minus 1 is 0. It is indeed a double root. That is my second root. How many do I expect? If I look back at my polynomial, I have 3 as my highest exponent. That's how many roots I expect. At this point, this is my, let's change colors. This is my x to the 0. This is my x to the 1. So I can set that up as 4x plus 1 is equal to 0. Subtract 1 from both sides. I have 4x equals -1. Divide by 4, divide by 4, and that gives me x equals -1/4. I also have x equals -1, and I have x equals -1. Those are my 3 roots, and I am done. I would recommend going through each problem and just finding the P over Q list, starting with that. Leave some room to do your synthetic division, and then finally go back and do the synthetic division, find your roots. I hope you find this helpful. I will try to put another one together just in case you need some extra examples. Good luck, and thank you.